Okay, in this video we're going to wrap up our series on asynchronous JavaScript, and we're going to be talking about the async and await keywords. Okay, the async keyword can be used when defining a function, and it ensures that the promise or that a promise will always be returned from that function. Okay, so here we just have a regular function, and we are calling the function, storing the value in x, and then logging it. So let's clear that out, and we're going to say 07 async await. Now we're using JavaScript modules, hence the MJS extension, and we see this just returns the value of 5. If I wanted to make this a promise, I could say promise dot resolve. Okay, promise is attached to the global object, and so we could say promise dot resolve, and this basically allows us to wrap a static value in a promise, and that automatically resolves. There's no possibility of it rejecting. Okay, so promise.resolve. We run this, and now we see node prints out promise. So this is a promise, and it shows us the resolution. That's just a nicety of node. Node automatically, if this thing has been resolved when you're logging it, it will unwrap it and show you the value if it can. Okay, but we actually, the object itself is the promise, right? So instead of doing promise.resolve, that's perfectly fine for something this simple, but we might have, an if or if else, and we might have lots of different return cases. We don't want to have to wrap every single one of them up in a promise.resolve. So what we can do is, if we go back to our static number value, we'll type async in front here. Okay, so this is the async keyword. You use it in front of a function definition. This is going to automatically, whatever value is returned, if it is a promise, it's going to remain a promise. If it's not a promise, it wraps it in that promise.resolve. Okay, so we should get the same output here. And sure enough, we do. All right, so let's change this from X now. This is actually a promise, right? So this returns a promise. And we see that returns a promise P. We already did this. Now we can do something like p.then, right? So with promises, you have the option to do a then. The then takes a function, right? Right, and then the result here is the result of the promise, right? And this will actually be the 5, right? So this should be the number 5. Okay, so this is a promise, but then when we do p.then, the function we pass in has a parameter. That parameter is the actual result or the resolution of the promise. Okay, so that's all good, right? The await keyword, let's move on to the next thing here. The await keyword can only be used inside of an async function or in the main body of a JavaScript module. Okay, so we are using .mjs, we are using JavaScript modules. We've talked about that already, about configuring modules, when that applies and when it doesn't. If you're unfamiliar with that, look back in the earlier videos of this series. So that's one of the benefits of using a JavaScript module. I can just use await in the global scope. It's pretty easy to deal with this in a regular JavaScript scope. You just create a main function and make that async and then call the main function. Now the reason for this is there is overhead for this functionality. Using promises and using async await, there is a little bit of computational overhead and memory overhead for doing something like this. It can be significant at times, so it is important to be aware, but in most cases the performance hit, or at least for small startup applications, for prototyping an idea, it's completely worth the trade-off. Now, if you're in a very large-scale professional environment, it might not be worth the trade-off. Okay. So at any rate, you can only use the await keyword inside of an async function or in JavaScript module. So we're in a module, and it's always going to unwrap the promise to the resultant value. Okay, so async always make sure that the function returns a promise, and then await will always unwrap any given promise. And it doesn't have to be a promise created with an async function either. Any promise, await will unwrap it for you. Okay. All right. so here let's define this result variable. We're going to say result, and we're going to get a value. Let's change this. Let's say we have arg, and we say if arg return promise.resolve arg. Okay, really simple. If we don't provide an argument, we just return 5. Okay, so get value is now doing that. So here we're gonna get value. This is from an async function, right? Get value we have defined as async. All right, we're gonna log the result, and then we're going to await the result. And we'll pause on, we'll comment this other part out for now. Okay, so from async, right, we log the result and we log the await. All right, now here, notice what we have here. It seems like it's kind of out of order. We have the original promise that had already resolved, right? And up here we got 5. But the problem here is this dot then on the event loop moves to the back of the line. Okay, all of our synchronous code has to finish executing before any of the thens finish, right? So here we've got a dot value or a get value, which is asynchronous, executing, and so that promise there is being logged out first before we get to this console.log of 5. Okay, now the await down here is going to the back of the line as well, right? This is basically like a then call, all right, because we're unwrapping the promise. It's like calling .then, so it goes to the back of the line that's after this then call, all right, which is why it seems like it's slightly out of order here. So these are all the things done currently in the event loop. As we call this one, or after we call .then on this promise that goes to the back of the event loop, we continue running code synchronously, right? And then there's an await, which means that goes to the back of the event loop. All right, and just to kind of visualize that, if we have this is the event queue, we have a promise. Let's see, promise 2, just like this. We create the promise. This is synchronous code, and then we duplicate this. This has to go to the back. This is the .then. Right, then the synchronous code executes, and we create the P2 promise, right? So this is actually creating this is where we await, which is essentially the same thing as a .then, and it goes back to the event loop. Then we finish processing that, and we pull the next thing off the event loop. Then we can console.log, pull that off the event loop, and then we can await the last item there. All right, so that's sort of how things work there. I'm going to undo this and go back to our original state there. We might come back to this. All right, so notice that this is all with the await function. It's equivalent to the .then, essentially. All right, and you have this result. So this can be set to just a variable if you want. So, you know, let result equal, you could put an await in front of this, right? That's allowed as well. So the await is when you're actually waiting and your program is pausing until the promise resolution comes through, right? So here, note that it also works with just regular old promises. It doesn't have to be a promise created with the async function. All right, so we can run this. All right, and here we have another promise. This one resolved right away. Now the reason for that is because with an async function, see this get value, this one did not resolve right away. There's an extra step before resolution, whereas promise.resolve is an immediate resolve. And we saw that up here with promise.resolve as well. Okay, so an async function, there's an extra step where if we go back to our event queue, there's an extra step of going to the back of the event queue line that there isn't in promise.resolve. That immediately has the terminology is to fulfill the promise. So a fulfilled promise is when a promise is either resolved or rejected. If one of those things is true, then the promise has been fulfilled one way or the other. Okay. All right, so that's just a promise. So we can use a await either way. All right, and let's go to the next. So one caveat of the await keyword is that the errors do not get unwrapped into a value, but instead are thrown like other JavaScript errors. You can try and catch as you would with synchronous JavaScript. Note that the try must surround the await, not the function call itself. Okay, so the awaiting is where we're handling this promise stuff. Okay, so the await part is what has to be inside the try. A lot of times you'll see code like this, await, and that's perfectly fine. And you could have a try block around this as well, and that's fine. But the await for async await, you have to have the await inside of the try block in order to catch the error. Okay, so we can try this. We're going to, we have a function, and just like we have promise.resolve, we have promise.reject. And so you can reject with anything you want. The common best practice is to reject with an error, just like you would get in a try catch. You get some sort of error. So that's sort of the standard. It may or may not be adhered to strictly in all teams, but that's generally what the standard is. So we're just going to call this my error. So this is always going to reject. And so we say get error cat, and then this is going to reject. So we have the try around, or the await, right? And so we should catch this error and log out the message. The error.message should just be this string that you provide when you instantiate a new error. All right, so let's try that. So there's my error. That's good. All right, and then one more thing, multiple awaits are allowed. So inside of a try block. So here in this case, we have await promise resolve, and we're going to log that out. Await promise reject, and then another await promise resolve, and another await promise reject. So we have error 1 and error 2. All right, and this, I'm not sure why that didn't copy everything. No, go down here, and we're just going to console.log that error.message, whatever it is. Now this is similar behavior to a promise, because if you recall, you do a promise.then, you can have as many thens as you want. The catch is going to catch an error from any one of them. Okay, so this is sort of like if you had several asynchronous calls, one after the other. The catch is going to catch the first one that happens, and you don't know, none of this other code is going to execute. Okay. And unless you examine the error carefully, you don't know exactly where this error occurred in your try block. That's why in general it's good to keep your try blocks small. All right, run this. Okay, and we need to maybe comment some stuff out so we can tell. It's a little tricky in async programming. I'm going to comment some things out to make sure we have everything. Okay, so we see we try to do this. We resolve cat. The await keyword unwraps that promise, essentially a .then, and returns that value so we can console.log. All right, and so we log out cat. Then we await this promise, but it's an error, and we immediately go to the error block, and we don't do these things. Okay, and error.message is my error. Right, I look up here, my error. Right, and so we can move things around a little bit. Let's do cat and dog. Those should succeed, and then we're going to put error 2 up above error 1, and now we should see cat dog and then error 2, and we'll skip error 1 because it came after the try. All right, so what's the purpose of all this? Why use async await at all? It's because it allows you to write code that looks synchronous. We're used to writing code that looks synchronous, and having to think about all of the asynchrony kind of makes things a little bit tricky. You have all the extra dot thens and dot catches, right? So this takes us back to sort of standard synchronous JavaScript syntax, right? And so we've sort of come full circle with async await. Now we can write asynchronous JavaScript and still have the usefulness, the ease of use of the try-catch statements and just standard synchronous JavaScript code. All right, so that's the premise. That's the idea. All right. So how does this help us with something like our callback hell example? So first, let's look back at our callback hell example. We had so a few different asynchronous functions. We are simulating these asynchronous functions using something called asyncify, right? We basically just wrap a timeout around them, right? We're simulating asynchronous activity here. And so we've got these three asynchronous functions, and we asyncify them here. Then we have a function called permissify, and that basically makes all of these async functions promises. All right, so we've got the same functions here, but they return promises instead. And what we've done is we get a user ID from the username, right? And then we log that out, and then we call another async function, and that async function requires that ID. Okay, so we return that promise. So then we call .then after this. It's going to be the result here. So .then is going to be the score. So that's what you get from the play game promise function. So that you get some score, right? Then we're going to log that out and then return the score. So this is like one single task, and it's sort of a chain task, right? There are multiple, there's two asynchronous function calls chained together, right? And in this task, it's the same series of asynchronous function calls, but it's for a different user. All right, so this is something that's very common. We have Alice and Bob. They each have their own chain of execution that needs to take place. Then once both of them have completed, right, promise.all, then we can determine a winner. So we have to have the usernames and the results of each person's score, right? And so with promise.all, you just pass in an array of promises. You get this results object back, which is an array, and the index values for the promises that you passed in are the index values for the results that come out. All right, and then we just call, we determine the winner. It tells us who wins, and then we have a .then at the end to let us know what's going on. And then just because it's good practice, we always have a catch at the end, right? That's how we did it. This is the promises version, right? So this is much better than our async callback hell version with the actual callbacks, right? We could take a look at that real quick too. With the actual callbacks, right? We had to keep track of when we got somebody's score back, because and then we had to check to see if we have gotten that person's score back yet, because we can only call determine the winner if we have both scores. And so in a callback chain, we have to manage all of this manually, right? So this is a lot harder to read, harder to reason about, but it does have advantages, right? And the callback system is a little bit faster than promises. It can make a significant difference sometimes, but it is much, much harder to read. And so that's part of the reason we have promises. So in computer science, there's always this balance between different things. It's a balance between computational performance and memory, perhaps, or in this case, computational performance and readability, right? And this all ties into costs, right? You have to pay your developers, and if it's harder for them to read these things, then they're spending more time, etc. Right? At least this is the reasoning. It may not be a good reason, but this is the reasoning behind some of this stuff. All right. So how do we do this with async await? All right. So we've got these permissified functions here. Everything above is exactly the same. We have the asyncify and then the permissify, right? So it's just a new file, and I've got async await test here instead of the promise test. Okay, so how do we go about this? First, we want to make an async function. All right, and we can say async function. All right, the async function guarantees that we get a promise back, and we'll just call this main1. And eventually we're going to be down here, and we're going to call main1. Right, so we should have a promise there. Now we want to let id1 equal get user ID promise, and we want to pass in user1, right? But this returns a promise, right? So what we have to do is add the await keyword, right? And now it's just like we're coding synchronously. I can just move right on. I can say console.log. I can log out. You know, this is the result of get user prom, and this is ID1. So just like in the other version, we were in the then statements, we were logging out our results. I'm just logging out the results, and I can just write code synchronously. It's really nice to look at things this way. All right. So then we can say, you know, finish this up. We could say let score. So this is all for Alice. Let score 1, await player game promise. Right. So this is a promise. So we have to await it to unwrap it. We had to pass in user 1's ID, right? Then we get score 1, right? And we log that out, right? So this is basically the entire first player task, all right? Now we're not doing the final step, determine the winner yet, because both of these have to complete. We have the other player to do first. So we have the Bob task to complete. So this is Alice's task, and then Bob's task. Okay, and by task, I just mean series of asynchronous function calls. It could be one or it could be many. All right, so here is Bob's task. All right, and once we've done both of those, then we can determine the winner. And again, the beauty of this is I don't have to worry about anything in terms of, you know, making sure that these have completed and worry about the asynchronous nature of things. I'm just going to call determine the winner because I have awaited all of these promises, so they're guaranteed to have finished. Now, I'm probably going to want to put try catches around all this stuff potentially, but for the sake of just showing how things work, I'm not going to go into all that depth. But here we await determine the winner, and we have user 1. We got that up here, or that's the original value, and score 1 is what we came away with after our task. And then we have user 2, and then score 2 is what we came with after the task. So this is going to print out the winner, and then we print a game over. All right. So we run this. We need 07.1. Okay. Okay. So starting, we get user ID. We pass in Alice, okay? So then we have to wait a little bit until we get that back. Now this is running. This is like the then. So we got user ID Alice. And so we have her user ID. It's 1,000, okay? Now we're going to start play game with that user ID, right? So it's asynchronous. It takes a little time. Then we start running it, and we get back a score. So notice here that Alice's entire task executed to completion before Bob initially started. Okay. Now the way we coded this here, it kind of defeats the purpose of asynchronous programming because we've just turned it into synchronous programming. We had to wait for Bob to come back, or Alice to come back completely before we could even start on Bob. So that's not ideal. Right? So what we would prefer is we would prefer something like this. So this is the synchronous version. We're going to comment this out. Yeah, and so now we want an asynchronous version. All right, and we're going to split up the task into its own function. Right? I'm going to comment out this code as well so it doesn't get in our way. All right. we have a task and we pass in a user and we get an ID back, and right, we have to await that get user ID, and again we log it out. That's fine. With that ID we can call get game promise, and we get a score back, we log it out, and then we return this. So this is an async function, so this is going to wrap this return in a promise. Okay, so now we can just call this task for Bob and for Alice. All right, so we have an alternative to the main1 function. We're going to call this main2 very cleverly. Main2. And so what do we want to do here? We want to call these two tasks because we need score1 and score2. Like ultimately we don't need the ID, we only need the ID in order for us to retrieve the score. So in order to determine the winner, we just need the usernames, which we already have defined up here, and then the eventual scores by running these tasks. Okay, so I have score1, I can run this task. So remember, async functions return promises. So I don't have the await keyword here. So this is going to be a promise. This is going to be a promise. So what's happening now is I'm starting both of these tasks before I'm awaiting anything. Okay, so these awaits don't take place until my synchronous code finishes executing. All right, so here we start off all of these things, and this basically creates promises for me. And if I wanted to do something, I could do promise.all, and I could just pass in score1 right? I could do something like that and get a dot then, right? But I would rather just await score1 and then score2. Okay, so what's nice is since I have already started them, they've already started executing. So I don't have to wait for one task to completely finish. So we're back to this asynchronous sort of nature, which is what we want. We want this to be more asynchronous because we want to be able to, while one asynchronous function is making a call, we want our program to be able to do other things, right? It should ideally make things faster for us, right? So we await score1 and score2, right? But really what we want to call is determine the winner, right? We want the promise version. There we go. And what is this? This is user 1, and then we can await score1, and then user 2, await score2. All right, and I don't need those awaits in there. And then I can call await here because this is, again, an asynchronous function. Okay, so wherever the await is, it's unwrapping the promise. And if there is no promise there, it just returns that value. So you can use these without promises. I don't recommend it. There's overhead for all this stuff. For using async and await, there is somewhat significant computational and memory overhead for using these things. So you only want to use them when it's appropriate. All right. So in this case, we could do something like try over all of this. We have multiple awaits. Something like this, because of the order of execution, I cannot call this function until I have evaluated these expressions, and that way I can pass them in as arguments. So the actual first await to go through is score1, and then the second await is to execute is score2, and then the final await in this try block would be the result, unwrapping the result of determine the winner. Okay, and so we can do something like accept. I don't know, this is, that's Python, catch error, and console.log. So we determine the winner error, and then maybe colon, and then error dot message. Okay, so this is the solution to using async await. It's much, much cleaner than anything we did previously. All right, if we run this, we see starting get user ID Alice, right? Starting get user ID Bob. So these both kick off at the same time, which is important because it's a chain of asynchronous calls. I don't want to have to wait for an entire one to execute, right? I want them to start executing, and then then my program can do other things while those are executing, right? And then that's the idea. All right, so this is Alice's ID, start play game, and then we come back and we're getting Bob back before we actually run the play game, right? So you can see that these are being interleaved, right? The execution of each one of the steps of these asynchronous function calls, right? Each individual step is being interleaved, and that's what we want. That's more efficient than having to wait for one entire chain to execute and then execute the next entire chain, especially if you had like 1,000 users, right, for a scoreboard or something like that. Right, so this is a better way of doing things. Look at the code is much cleaner. Again, there are potentially computational costs as well as memory costs to this. So only use it where you need to. Okay, so that is the callback hell fix using async await. And so why have we been talking about all this? Well, basically we're going to want to interact with a backend system sometime. And right now, the best way to interact with a backend system, making a network call to the system. If you have a web page, your JavaScript might want to make a network call to your backend service to get a user, get some user information, or add something to a user's cart, or make a purchase. So you're always going to have to interact with a backend system in some way. So there's something called the Fetch API. Okay, API is Application Programming Interface. The Fetch API is a way to make web requests. This used to be fairly painful in older versions of JavaScript. Fetch, I think, came out in around 2015, maybe sooner. There were implementations of it, but the idea here is Fetch returns promises. All right, so when we look at this, we're gonna get a promise back from Fetch. So let's just call Fetch with no URL, and what we get back is an error, and we can look at that error message. I'll log all this stuff out, or comment all this out. All right, so fetch with no URL is an error. Let's run this. 7.2. Okay, failed to parse URL from undefined. Okay, this argument is undefined. Right, so that's the error message we get. All right, let's go ahead and call fetch. We're gonna fix this, right? So with promises, you can do .catch and use a .catch when you want to fix the problem, and then continue on with the chain, right? So here we're continuing on with .then by calling fetch, and we are going to use the appropriate URL. So notice here I just have a text file. I can put this into a browser, and we can see what we get back. Right, so this is just my name in a text file. There's no HTML to this at all, but we can still get it. We can still get it back with fetch. All right, so this is the URL, and so fetch. I'm correcting the initial error, and then we have our catch. So again, catch is for correcting any errors and then continuing the chain. So now we're going to correct this. So now we should get a response back. What's the response? It should be what we get back here from the browser. It should just be my name, Luke Benjamin May. All right, so let's pop back and see what we get from that. Then response, unexpected token. Oh, I had to put a semicolon there because I had commented out the code. All right, Failed to parse URL from undefined. Then we get status 200. Okay, so this response object you get back from fetch has a lot of things on it. So if you're familiar with networking and HTTP, there are HTTP status codes. A 200 code is telling you that everything worked out. The status is 200. So I was able to contact the server, and the server responded with your request. So 200 means everything's great. Okay, so I'm printing that out. And then the next thing I'm doing here is I'm returning response.text. Okay, it's because my web page, the thing that I'm getting back from the service is just supposed to be plain text. It's not supposed to be HTML. It's not supposed to be JSON. If you do have JSON, which is one of the most common ways of interacting with a backend service, JSON is JavaScript object notation, right? Basically just looks like JavaScript objects. You can, instead of this, you could say response.json, and you'd get a JSON object back. Now, it's important to note that this is an asynchronous call. Okay, that's because parsing, depending on the size of the object, can take a lot of time, right? And so this is done in a separate asynchronous call, and then when you get this back, you get the text, right? So we're returning, this is a promise, right? And so we can call dot, then on that promise, we get our text, and then we just log that text back. Okay, so our initial fetch failed, we fixed it, then we get a 200 back, then we parsed the data back out, and we get the text. Okay, so this is with the traditional promise. Now, with async await, we could take a look at what that looks like. Okay, so let's do this. We have a function main. Technically, this is a module, so technically we don't even need that. That function main stuff, we can ignore that. So we have a response. I'm defining the response outside of the scope of the try catch because I use it in both places. So again, remember, like the catch up here, the idea of a catch interwoven between other then calls is to correct the mistake and then continue. So here, if there is a mistake, we go to the catch and we want to correct it, right? So I have to still have access to this outer scope response, and we're using await on each of these. And theoretically, there could also be an error here, so you would have another try, right? So it does get a little bit messy with try catches, but it's no different than it gets in normal JavaScript with try catches, okay? So the idea is it moves us away from that callback hell area to somewhere that may be still tricky, but it's at least what we're used to. It's the synchronous JavaScript land that we all know and love. All right, so here's our response. We're correcting the issue, and we are awaiting. So this is just a variable. Await is going to unwrap that value. So this response, we get that back. We can still do a console.log status, and that should be 200 after our catch, right? And then we call response.text. Again, this is a promise, so we call await. We get our text back, and then log. Okay, so this is nicer than this. At least that's the argument. Right? So await is really nice. It just makes asynchronous code look and behave more like synchronous code. Now, it is important to understand all this, though, because it's doing something different under the hood than synchronous code. And if you don't understand how all this works, you can have a really hard time with the subtle differences in behavior. Okay, so it is important to know how all of this is working. That's why I went to all the trouble of making this video series on asynchronous JavaScript. All right, so let's just confirm that this works. We'll run this, and sure enough, with our async code, it worked just fine. Our async awaits, we're running in a module, so we can use await without having to define that async function. All right, Final thoughts, and I've mentioned this before, but promises are computationally expensive and consume additional memory. They can also be very slow. Each then sends the next execution context to the back of the event queue. And I'm going to pull up that diagram again here. So this is, in a way, exactly what we wanted with the async programming, but it also can be very bad in certain situations. So imagine we had a backend server handling client requests, and it uses promises, right? And so it gets a request. That's an asynchronous call to go look in a database, and an asynchronous call to maybe parse some information, and then return a value, right? So imagine a task that has 3 async calls, right? Or 3 .then blocks. So now let's say that the server, when it gets to its point in the event loop, it starts executing the events. We have a spike in traffic because maybe it's the holidays. And when we get there, there's 1,000 events waiting for us in the queue. All right, that's fine. So we start processing these 1,000 requests in the event queue, right? And because of the nature of each .then moving to the back of the event queue, that means all of the 1,000 requests start processing before the first .then of the first request, right? And even worse than that, the second .then of the first request doesn't process until all of the second .thens of the other 1,000 requests. So this can make response times very, very slow, right? So you have to be aware that this can happen. In most situations, it's not a problem, right? But this particular situation is something that can happen. And if we look at sort of a drawing here of how that works. So we have P1, P2, and so this is the event queue, right? The back of the queue, everything goes in this direction. And we have 1,000 other promises. So I start, this is my backend system. So I got a request from a client and I need to go get something from the database, right? So while this event is executing, this is going to be my P1, and it could be a .then or it can be an await, whatever. Either way, that goes to the back of the line. So this is processed. And now all these other 1,000 elements move up. But my P1 is at the back of that line, right? Same with P2. It goes back here. This is the P2 .await now. Right? And we still have these 1,000 other initial events to process. So we get through all of those, and finally P1 await and P2 await are here. And all of those, we have 1,000 other awaits back here. Meanwhile, while this is happening, you could be getting more requests into the event loop, right? So maybe in this first process, while I was executing those first 1,000, maybe I got another 1,000, right? And so instead of just 1,000 elements here, I now have 2,000 elements in my event queue, right? And so now we have our second await for P1, and I have to put that at the back of the list. All right, and now there's 2,000 items in the list here, right? So this would be, 1,000 awaits, and then 1,000 new requests. Right? And then we have our P1. This is our second await. And we go through this one, and these come up, right? And these would be interleaved between these, right? It's not necessarily 1,000 and then 1,000, right? They would be, as the traffic comes in, right? You would be getting these events stack up in your queue, right? So this is more, they're more together. It's hard to say exactly. But at any rate, that's 2,000 items that have to be processed before you get back to here. All right, and so this makes just satisfying the one request really, really slow. If you did it a different way, where the entire chain of elements executed, or the entire chain of asynchronous tasks executed one after the other before we moved on to the second request, at the very least, the people who got their request in first would finish quickly. With this type of situation, though, pretty much everybody has to wait a really long time, right? So again, in computer science, it's about balancing resources, and you have to decide what's acceptable and what's not. Okay, and so Asynchronous programming is everywhere in web development. It's a really, really critical piece, and it's somewhat confusing. It's hard to understand. That's why we spent so much time on it. But that's essentially the nuts and bolts of asynchronous programming. All right, so hopefully these videos helped you, and that should conclude the series. Thanks for watching.